Hello students, welcome to this video on tutorial 4 where together we will solve question 5 and question 8 of the tutorial. Now, in question 5 you are asked to use the Gauss reduction operation to find the determinant of A, calculate the adjoint of A, and find the inverse of A. So, this is matrix A given and you are asked to find the determinant of A. So, let's have a look on how to solve this. So, determinant of A is equals to 1, 4, 3, 2, 1, minus 1, 3, 2, minus 2. So, using the Gauss reduction, I see that this is the pivot of the first row, right? So, what I will do is that I need 0 to be here and 0 to be here. So, I will do that R2, right, will equals to R2 minus 4 R1. And then R3 will be equal to R3 minus 3 R1. And this will lead to the following determinant: 1, 2, 3, 0 minus 7 minus 10, 0 minus 7 minus 11, right? So once I have that, what do I notice here? I notice here that so I can also do that. I can make 0 here. So this will be, if I do that, R3 equals to R3 minus R2. Okay, so this will lead me to the determinant, right? 1, 2, 3, 0 minus 7 minus 10, 0, 0 minus 1. Okay, so what do I see here? Here I can see that the lower diagonal have the 0, 0 term. So this matrix in the determinant is a lower triangular matrix. And from what we saw in the previous video, using the properties, we saw that the determinant of a lower triangular matrix is equal to the product of the element of the diagonal. So this is will be 1 minus 7 minus 1, which is 7. So the determinant of A is 7. Now, let's have a look on the second question B, where you are asked to find the adjoint of A. So we know by definition that the adjoint of A is the cofactor matrix of A transpose. Now, having A given as 1, 4, 3, 2, 1 minus 1, 3, 2 minus 3, we need to find the cofactor matrix. And to find the cofactor matrix, we need to make use of the minor matrix, and then we need to also make use of the place sign. So if I have plus minus plus minus plus minus plus minus plus, so this is the place sign matrix. Now let's find the minor matrix of the element of A. So if I want to find M11, that is this element, right? What I do is that I do this. So what is remaining is 1 minus 1, 2 minus 2. And M11 gives me 0, right? So if I want to find M12, right, then this pivot here, I do this. I will remain with 4, 3, 2, minus 2, right? If you give me minus 8 minus 6 minus 14. If I want to find M13, right, it is this. I do this, I do this, and this. Remain with 4, 3, 1 minus 1, which is equals to minus 4 minus 3 minus 7. So, and then I can also find the M21, right, which is this here. So I do this and I do this, right? So I remain with 2 minus 1 and 3 minus 2, right? So this will give me minus 4 plus 3 minus 1. So if I want m to 2, right, which is this this term in here, the middle. So doing this and this, right, I will have to stay with the 1, 3, and then 3 minus 2, right? So when I do m to 2, and then this is minus 2 minus 9 minus 11. So you can do the same process and you find m to 3, right, which is minus 7, and you find m31, right, which is 1. You find m32, which is minus 10, and you find m33, which is minus 7. So having all these elements, I can therefore build the minor matrix. I can build the minor matrix of 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 A. So I will have that the minor matrix will be 0, minus 14, minus 7, then minus 1, minus 11, minus 7, 1, minus 10, minus 7. So this is the minor. And then let me just also give you a reminder of the place sign matrix here, right? And we know that the definition of a determinant is given as such, right? So we have this term here, which is already explicitly defined in the place matrix, the place sign matrix, and then here we have the minor matrix of the element of A. So this m we already have it here, and this term here is defined here as a place sign matrix. So therefore, to have the cofactor of A matrix, what we do is that we multiply each term by its corresponding place sign. So if I do 0 times plus is 0. If I do minus 14 times minus is 14, right? If I do minus 7 times plus is minus 7. If I do minus 1 times minus 1, I will have 1, right? Then minus 11, then 7, then 1, then 10, then minus 7, right? Therefore, the adjoint will simply be the cofactor transpose. So I will have to transpose this matrix, right? Which is equal to 0, 14, minus 7, 1, minus 11, 7, 1, 10, minus 7. I have that. Okay, so I have the adjoint. Now, if I want to find the inverse, right? If I want to find the inverse of this matrix, I know that the inverse of A is 1 over the determinant of A times adjoint of matrix A. So I already have a determinant 7, right? Then I can just write the adjoint matrix. Yes. Okay, so I then have that my inverse of A equals to 1 over 7. 0, 14, minus 7, 1, minus 11, 7, 1, 10, minus 7. So this is the inverse of my matrix A. So in this video we answer the three questions that were asked at the very beginning. Use the Gauss reduction operation to find the determinant of A, right? So we got it, and then find the adjoint of A. You saw how we did it step by step, and then find the inverse. And in this video we went together step by step to find the determinant of A, the adjoint, and therefore finally we were able to access the inverse of matrix A. Thank you for your kind attention.